Get ready to shatter some mind-blowing misconceptions about the ultimate cosmic monsters, black holes. Before diving into their explosive secrets, let's first break down what these mysterious entities truly are. Contrary to popular images of a cosmic vacuum cleaner gobbling up everything in sight, black holes are actually regions in space where gravity is so intense, not even light can escape once it crosses the point of no return, known as the event horizon. Think of it like an invisible sinkhole that warps space and time around itself. Let's flip the script on black holes. Contrary to what you might think, a black hole isn't actually an empty void. It's more like the ultimate overcrowding situation. These cosmic powerhouses pack the maximum amount of matter into a teensy-weensy space, and that's what causes gravity to go utterly crazy. In fact, gravity gets so intense at a black hole that not even light can break free. Talk about a warp in space-time. So, it's not that you're sucked in because there's nothing else around, it's just that the gravity is so overwhelmingly strong, it outpaces the speed of light, making escape impossible. Get ready to have your mind blown. Tiny, dense objects with crazy strong gravity. They're called black holes and they form in some seriously explosive ways. Usually, when a star around 25 times bigger than our sun runs out of fuel, boom, it goes supernova, releasing its outer layers at incredible speeds. But the core, it gets squished, compressed by its own mind-boggling gravity. If it's got enough mass, this super dense core can morph into a black hole. Get ready to meet the ultimate cosmic giants. After this incredible explosion, our star will leave behind a stellar mass black hole. Basically, its grown-up version packed with a few times the sun's weight. But that's not all, folks. In space, there are these legendary behemoths called supermassive black holes. Imagine them residing at the heart of galaxies, and they're absolutely humongous. These space monsters can weigh millions or even billions of times more than our star, the sun. Buckle up, space fans. Scientists think that supermassive black holes and their galaxy homes might have grown side by side since the universe was born. But we're still trying to crack the exact timeline. Now, let's talk about what happens if you were unlucky enough to stumble into a black hole. Game over, right? Well, it's true once you cross that point of no return, there's zero escape. But here's the thing: before you even reach it, intense gravity would have ripped your body apart. The closer you get to any object, the stronger its gravitational pull becomes, and a black hole's gravity is no joke. Imagine being pulled into an astronomical monster, a stellar mass black hole. As you descend headfirst, gravity's grip on your feet becomes so intense it's thousands of times stronger than its pull on your poor head. This mind-blowing difference in forces stretches you out like sticky taffy, and scientists irreverently call this bizarre phenomenon spaghettification. By the time you reach the black hole, you'd essentially be a long, thin strand of matter, miles long, and not even feeling the strain. Imagine you're plummeting towards Earth from space. Sounds intense, right? Well, if we're talking about a black hole, it's like that drop, but on steroids. Matter can get sucked in before it even reaches the black hole itself. Some black holes snatch nearby stars or gas clouds. As more matter is pulled in, it forms a disk just outside the black hole. Think of it as an orbiting feeding frenzy. The stuff in this accretion disk moves at incredible speeds and gets scorchingly hot, reaching temperatures of millions of degrees Celsius. Get ready for some mind-blowing facts about black holes. First off, these cosmic monsters don't just suck you in and rip you apart. They also blast you with intense radiation, like super powerful X-rays, long before that even happens. Now let's talk types of black holes. We've got three main categories: intermediate, supermassive, and microscopic. So what sets them apart? Well, an intermediate black hole weighs in at around 100 to 100,000 times the mass of our sun, while a supermassive black hole is the real behemoth, packing billions of solar masses. On the other end of the scale, microscopic black holes are tiny, with some weighing as little as 22 micrograms. And what about this? Can black holes actually explode? Imagine a cosmic vacuum so powerful that not even light can break free. Welcome to the world of black holes. These space monsters are governed by laws we're still trying to fully grasp, and what happens inside remains somewhat of a mystery. One thing's for sure though, our current understanding of physics crumbles near these behemoths. As they grow, their grip on everything around them tightens like an unyielding fist. They're the ultimate hoarders, sucking in whatever crosses their path with no intention of giving up their cosmic treasures. Imagine these tiny monsters, supermassive black holes in disguise, growing stronger no matter what you throw their way or how you try to manipulate them. But here's the wild twist. Stephen Hawking cracked the code on these mysterious objects and discovered they're not completely invincible. He proposed something called Hawking radiation, a mind-blowing energy release that happens with even the smallest of black holes. The craziest part: these teeny black holes can actually vanish into thin air. Yes, you heard that right, evaporate. But there's a catch: they need to be tiny, and it takes an unfathomable amount of time, like billions of years, for this cosmic meltdown to occur. Buckle up, space fans. Let's dive into the Big Bang mystery. We still don't know for sure what sparked our universe. Scientists have a few wild ideas like string theory, but honestly, they're just super smart guesses. So the starting point of everything is called the singularity. It's a teeny tiny dot with no size or shape, kind of like an invisible magic button. Don't worry if you associate singularity with black holes too, that's just a cool coincidence in naming. Now, math whizzes can tell us what was happening super fast after the universe started expanding, but unfortunately, we're still clueless about its initial secret. So here's the deal: black holes aren't going to blow their tops and have some kind of cosmic explosion. They're actually going to slowly fade away through something called Hawking radiation. Now, you might think it's crazy for anything to escape from a black hole since they suck stuff in like vacuum cleaners. But this radiation is a tiny bit of energy that leaks out over time, eventually leading the black hole's demise. If a black hole were close enough to Earth, it'd be game over. Everything would get pulled in, including our planet, and life as we know it would cease to exist. But here's an interesting twist in theory. Under extreme conditions, a black hole could transform into something called a white hole, which would do the exact opposite, pushing everything away from itself. Think of it like a cosmic ejector seat. But instead of blasting stuff out, it'd be creating a new pathway for matter and energy to flow through. You made it to the end, which means you got some awesome knowledge packed into your brain. Let's recap what we covered, our top tips for tackling that tricky math problem that's been stumping you. What do you think will be the most helpful one for you to remember? Share in the comments below.